Hey guys, for this section 12.4, we're going to talk about segment lengths. We've actually already brushed on section 12.4 before, but that was talking about angle measures. So now we're just focusing on lengths. So we are not talking about angles or arcs today. So do not think degrees, do not think 360, do not think 180. We're just talking about lengths. So let's talk about chords inside of a circle. So I'm going to have you draw this with me. Let's say we have a chord that passes the circle twice like this, and another chord that also passes the circle, hits it twice. Now when these two chords intersect, they make four parts. I'm going to use lowercase letters to kind of represent these parts. So you have this first part, we'll call it A. You have the second part, we'll call it B. And then this third one, we'll call it C. And this fourth one, we'll call it D. If I want to find the length of any of those parts, I'm going to use this property. The product of chord 1 equals the product of chord 2. So basically, let's analyze the two chords that we drew. The first chord we drew was this one here that consisted of parts A and B. So we are going to multiply those two parts, A times B. And then the other chord that we had drawn consists of parts C and D. So we're simply going to equal this to C times D. And then that's how you would find a missing length if I gave you numbers in the picture. So let's actually do an example here. So for example 1, I have two chords. I can see the four parts that have been created, and I'm missing one of the parts. It's called X. So we're going to solve for X. So again, we're going to use that idea of taking the product of chord 1, and we're going to equal it to the product of chord 2. So it doesn't matter which chord you start with. Let's say I start with this one here that consists of 6 and 10. I'm going to multiply those two parts together, and I'm going to equal it to the other chord that consists of X and a 5. From here, it's just algebra. So 6 times 10 is 60. X times 5 is just 5x. And then you divide. So X will equal 12. So that is the length of this missing piece of the chord, 12. Go ahead and try example 2. If not, just keep watching the video and I will walk through example 2. So for example 2, I'm going to use this property again. Product of chord 1 equals product of chord 2. So I'm going to start with this first chord. I can see that it is made up of 6 and an x plus 4. So I'm putting that whole thing in parentheses. I'm going to set it equal to the second chord, which consists of x and a 12. So for this one, we're going to end up distributing that 6. So we get 6x plus 24 equals 12x. And again, it's just algebra. So we can subtract 6x over 24 equals 6x. Divide by 6. X equals 4. Okay, so now let's talk about tangent lines and secant lines. So I'm first just going to talk about secants, because it's the one we're least familiar with. If you guys remember, a secant is a line that starts in space, and it hits the circle not only once, but twice. And then it can keep going, I'm just not going to draw it. So let's actually draw two secant lines. And I'm going to have them meet at this external point. Now, as you can see, when I drew these two secant lines, it's the lines are being split up into 4 parts again, just like in our last slides. So I'm going to call this first part A, I'm going to call this second part B, and then down here I'll call this C and D. Okay, so that's what it would look like for 2 secant lines. Let's do an example where I have a tangent and a secant line. So if you guys remember, a tangent is just a segment that starts outside the circle, touches the circle once, and then it can keep going. I'm just not going to draw the rest of it. And then let's draw a secant, so it's going to hit the circle twice. Now, whenever you guys have a tangent and a secant, it really only makes 3 parts. I have this segment here, which we'll call A, and then I've got this one we'll call B, and this one we'll call C. So let's say I want to find length of any of these parts. This is going to be a little bit different than what we just did with the chords. We're going to use this property. The total length of the secant or the tangent times its outer length will equal the total length of the other secant or tangent times its outer length. So let's take a look at the first picture here. If I were to look at the very first secant that we drew, I'll highlight it in red here. The total length of that is going to be A plus B. Because whenever you guys are finding total length, you add. Now I'm going to multiply that by the outer length of that secant. So the outer part, the part outside the circle, is B. That's going to equal the same thing for the other secant. So if I look at the other secant, the total is going to be adding up C plus D, and its outer part is going to be D. And again, this would just be algebra. If I give you numbers, you would just plug in the numbers and then just follow the property. So I'm just going to duplicate this, and we're going to do the same exact thing for this scenario, which is a tangent and a secant. So let's start with that tangent. So that tangent is just made up of A. So the total length of that tangent is just A. Now I'm going to multiply by the outside part of the tangent. Well, the outside part of this tangent is also A. So anytime you guys are working with tangents, the total length of the tangent is going to equal the outer length of the tangent. Now we're just going to take a look at the secant. So the total length of the secant is going to be B plus C. And then the outer length of that secant is going to be C. Okay, so let's go ahead and do some examples. So I'll do example 1, and then you might want to try example 2 and maybe pause the video and then switch back and forth, watch example 3, try example 4. All right, so let's look at example 1. So I definitely have 2 secants here. I have 4 parts, and I'm going to use that idea of taking the total length of one secant, multiplying it by its outer part, and it's going to equal the total length of the other secant multiplied by its outer part. All right, so you can start with either of the secants. I'm going to start with this first one here that I see on top. So if I want to find the total length of that, I'm just going to add 6 plus 4. Total length is 10. I'm going to multiply it by the outer part. Well, the outer part is clearly just 6. So that concludes my first part here. And I'm going to do the same exact thing with the other secant. So if I look at this secant, the total length is going to be adding 5 plus x. Now I'm going to multiply by the outer part, Well, the outer part is just 5. All right, everything from here is just algebra. 10 times 6 is 60. This is just a backwards distribution, so you're going to get 25 plus 5x. Then we can subtract 25 from 60. We'll get 35 equals 5x, and then divide x is 7. So that's this missing piece here. That would be 7. Okay, feel free to pause the video, try example 2, or just keep watching. So for example 2, we're going to do the same idea. Total times outer for one secant will equal total times outer for the other secant. So I'm going to look at this first secant, RT. If I want the total, I got to add up the two parts, 3x plus 15. I'm now going to multiply by its outer part, which is just 15. All right, let's set that equal to the other secant. So its total would be x plus 20. And its outer part is just going to be 20. Okay, more distribution here. It's just backwards. So 3x times 15 will be 45x. 15 times 15 is 225. Same idea over here. 20 times x is 20x. 20 times 20 is 400. We could subtract 20x over to get 25x. We could then subtract 225 over. So 25x equals 175. And then divide. We're also going to get x equals 7 for this problem. All right, let's keep going. Let's look at example 3. I'm not going to write the equation out or the property out. I'm just going to kind of follow what we've been doing. So I'm going to look at my first secant here. I know that I want to start with the total. Well, they actually give us the total. The total is just x. So I don't have to actually add anything. Now I'm going to multiply by the outer part. So the outer length is 5. All right, I'm going to set that equal to the total length of the other secant. 4 plus 6 is 10. And I'm going to multiply that by the outer part, which is 6. Okay, x times 5 is just 5x. 10 times 6 is 60. We are going to divide. X equals 12. All right. When you look at example 4, you'll notice you only have 3 parts. That's because you have a tangent and a secant. But we're still going to do the same exact thing. So I'm going to start with, I don't know, let's start with my tangent here. What's the total length of the tangent? Just 31. What's the outside length of the tangent? Again, it's 31. I'm going to set that equal to the total length of the secant. So that means I'm going to have to add x plus 20, since it doesn't give me a total length. And I'm going to multiply by the outer length, which is 20. Okay, so 31 times 31 gives us 961. Distribute that 20, so you got 20x plus 400. We could subtract 400 over to get 561 equals 20x. And then divide by 20. We are going to get a decimal, 28.05. Okay, last example. This one also has 3 parts, so you know that it has a tangent and a secant. So I'm going to start with the secant. So what's the total length of that secant? 24 plus 3 is 27. And I'm going to multiply it with the outer part, which is 3. And we're going to set that equal to the total for the other tangent, which is x, and the outer part for the tangent, which is also x. So 27 times 3 will give us 81. And you have to ask yourself, what is x times x? Not 2x. It is x squared. And then how do you guys get rid of a square? You take the square root. So this actually comes out to a nice whole number. X is 9. All right, so that's it for 12.4 segment length. Let me know if you guys have any questions. Enjoy your night.